Good evening. My name is Frank Rollo, and I'd like to start by thanking Oscar James for feeding me such a wonderful meal. I'm going to touch on some of the topics that Tom spoke about, and then go into the subject of specifically Area E2, and then discuss with you the liquefaction that is probable in that area, and then look and speak to you about ways of mitigating and or eliminate the risk of that liquefaction. Tom is a humble man. After the Loma Prieta earthquake, the governor of the state of California, Deukmejian, had enough money in the budget to allow for a study of liquefaction in the northern portion of San Francisco and in Los Angeles. And Tom coordinated the effort of the northern portion of San Francisco as well as the southern portion of San Francisco study, and it was published in a report that he authored called The Loma Prieta California Earthquake of October 17, 1989. And it's available, I'm sure Tom has told you, it's available online. As a result of that, as a part of that process, the USGS met with the geotechnical community, reviewed a lot of data related to the 1906 earthquake, as well as information that was garnered from the earthquake of '89. And as a result of that, they developed the what's called seismic hazards map. Copies of this map are over on the table next to the entrance, and I encourage you all to take a copy home and use it as wallpaper. But basically, Hunters Point, portions of Hunters Point were identified as potentially liquefiable. In 2004, the Navy commissioned a study to look specifically at Area E2, which is the area where the solid waste landfill is located. Area E2. They retained the firm of Tetra Tech, who did extensive investigations in the area and concluded that yes, the soil, the sandy soil below the groundwater level will liquefy. Now, when I talk about the sandy soil, I'm going to move over to this figure, and this is a slice taken through the site, and you're actually, if you were standing looking at the subsurface, if you were standing in the bay looking at what the soil conditions are like from the ground surface down. This represents the ground surface. This red represents a cap of compacted material that was placed by the Navy. The yellow, all this yellow, represents sand, both as fill that was placed by the Navy or natural soil that was placed in geologic times up to a couple 100,000 years ago. What the results of the study concluded is that most of these yellow sands will liquefy. So this map is correct as it relates to E2. What does that mean? That means that there are random lenses of sand below the water level that will turn to quicksand during an earthquake. And two things happen when liquefaction occurs. Number one, as Dr. Holzer pointed out, there is a tendency for migration of water up through the soil and manifest itself as sand boils, little volcanoes, at the ground surface. The other phenomena that occurs is the ground will settle. This study predicted that approximately 10 inches of settlement of the ground surface will occur as a result of liquefaction. Another phenomenon that occurs with liquefaction is what's called lateral spreading. Lateral spreading means that the soil flows to an unconfined surface, in this case, the bay. So there will be a tendency during the earthquake for the liquefiable material to flow laterally toward the bay. Okay, we've recognized the problem. The problem number one is that there are sand lenses present that will liquefy during an earthquake. Number two, by the way, the earthquake that they used in this study was a magnitude 7.9, which is the maximum capable earthquake that's predicted if the entire San Andreas Fault were to rupture. The accelerations, that is the shaking that would be associated with that, is on the order of half of g, half of gravity. To give you some comparison, in 1989, the acceleration, the maximum acceleration that was measured in the Bay Area was at the airport, and the acceleration was about 0.2 g. So this could be up to 3 times stronger. So we now know that when that earthquake occurs, we're going to get liquefaction and lateral spreading because the sands aren't strong enough to resist. So what do you do about it?